I'm Jay Williamson, and this is Catherine Fiore, and we're
Mhm.
coming from Cornell University, the Center for Teaching Innovation. We are actually part of a pretty unique partnership with the Nanoscale facility on campus, and we've been developing immersive learning content about semiconductor manufacturing. So those are the chips that go into a lot of the headsets and all of our devices. And we're making workforce development training. So we were able to receive a 3D CAD model from one of the industry manufacturers, which is a really high polygon count model. And we were just trying to see what we can do with it. So this experience is set kind of in a lab where you're meant to walk up to this tablet that we have that will have all of the instructions for how to actually operate this machine. This machine is a sputter deposition tool. So what it is doing is going to use plasma to strike a target of a certain material. So it would be something like platinum or titanium. And then it's also under high vacuum pressure. And when that target is struck by the plasma, that material then flies up onto the glass substrate, and that becomes one layer of a chip. So this is just one piece in the manufacturing process, but we wanted to show them how step by step you're going through the tool, because this is a $500,000 tool, and there's 3 of these on campus. And if someone were to, vent the chamber a little too soon, all of the air that's not under vacuum pressure would zoom into the chamber and actually turn into a block of ice. And so there's a lot of safety concerns and also the health of the tool. So we got a lot of these steps that walk you through where to go on the tool. I would love to add more instructions here to really get you to understand the tool, and then also be able to do like a practice session where you don't have the instructions there, or you could toggle them off so you can test your own knowledge there. But yeah, this was a lot of fun to work with the model. Honestly, half of the work for building this was just working with the CAD model and grouping all the right parts together, and then kind of figuring out where do we put the interactions on the tool, so that if you feel like you're reaching for it with your own hand, but also making it a little easier to turn around in this quick prototype session. So we added some little trigger cubes that have instructions, and that what just opened there was the light. So that's the plasma that you get to see on the tool. And so a lot of it is the same interactions in the reverse after the sputtering has happened. But just little reminders on this tablet can help you go through the steps in the correct order and build that muscle memory. Anything else to add there?
Yeah, no, I mean, Jay was really the brains of this operation. I kind of just was supporting in smaller ways whenever I could. So that's why, yeah, definitely did a fantastic job pulling this all together. I mean, the big thing that this really was coming down to is trying to get comfortable with this physicality, this presence of being next to this tool, so that when you do step into the clean room, you're not overwhelmed by everything. So
then you grab your wafer, and that is ready to move on to the next tool, because honestly, there are so many steps and layers that go into creating just a single semiconductor chip. We've learned a ton about this whole process coming from the media background, but it's been really, really a lot of learning.